Hi, I'm Clark on Temptress. Today we're going to go over how to wire up the anchor windlass. That's that big winch on the front of the boat, usually electric, that pulls the anchor up and helps you put it down. They are mechanical devices. They live in a particularly bad environment up there with all the chain in the chain locker, and their wiring goes bad often. It's very important you know how to fix it when it fails. Why I'm doing this video is mine just failed. I haven't used the windlass on Temptress in a while. As you know, we've been in this bay for a while, starting to get the boat ready for bigger things, and I realized that the windlass didn't function. Now, the windlass is, as I said earlier, the device that helps you pull your anchor up. That's kind of its main job. There are various kinds. There's horizontals and verticals. I use a vertical. They either have a caspin, so you can throw some rope around it and have it be like a powered winch that helps you pull up a rope anchor rod, or they have a gypsy, which is the part that the chain can go into. I have both on mine, but that's unimportant. What's important now is if you have an electric windlass, let's figure out how to make the darn thing work. Now, some windlasses just pull the chain up, and some of them have the ability to power it up, but also power it down. That's very, very handy, especially if you have all chain, because that can help you actually pull the chain out of the locker. But it also lets you have remote control over your windlass. And we're going to go into that too, how to get a remote control switch onto the windlass you probably have now. I use that myself when I'm sailing alone. I can prep the anchor and let it go just over the side, so it's ready to fall. I can come into what might be a difficult anchorage and get the bow just exactly where I want that anchor to be. And then instead of having to run forward and the boat is drifting and everything is changing, I can push a button in the cockpit that tells the windlass, now's the time, and it'll start dumping chain. Now I do that for a while, basically till the anchor's on the bottom, and then I, slip into neutral, run forward, and do the rest up there. You really want to do the whole windlass operation, if possible, right from the bow of the boat so you can see if something goes wrong. But sometimes you've got to do what you've got to do. Also, when I leave and I'm alone, if it's a very crowded anchorage, I will bring it right up onto very short scope, so it's barely holding, run back to the cockpit, use the transmission to put the boat right where I want it, and then just lift it up off the bottom and up a bit at least, with the remote switch, and then I can get out to where I have some room to maneuver, and then I can put the anchor away properly. So let's dive into windlasses. Windlasses are a big electric motor. In fact, I think I'm going to draw it out here. So let's put the windlass here. So I'm not the best artist, but my windlass looks vaguely like this, where this is the chain gypsy and this is the capstan for the rope, and then the deck of the boat, and down below the deck of the boat there's a really powerful motor and a gearbox. We're going to assume the windlass itself is functional. We're just going to assume the problem is the electricity going to the windlass. 99% of the time that's what's wrong with it. So in my case, I have 3 wires that run to the windlass. I have a wire for ground. Let's do this in black. So I have a wire for ground, and that's where the battery's negative goes to. And then I have 2 wires for positive. We have one terminal that is up and one terminal that is down. And very simply, if I apply positive to up, the anchor will spin in the direction that pulls the anchor up. And if I apply power to the down terminal, it'll do the opposite. It'll push out anchor line. Now, you're going to have some switches to control this. And on smaller windlasses, you could just have switches that directly control this right from the battery. That's not done so often in bigger windlasses because you need to push more power than the switch could really comfortably have a long life at. And also, if you want to do that remote trick, you absolutely have to do it this way. And what you do is you put these things in. These are continuous duty solenoids. And this is what they look like when they're spare and they're in your drawer, and they fail very often. So I highly recommend you keep a spare in your equipment drawer. I pulled these out because I was good. I had them. This is what came out of the windlass. These are corroded up on the outside, but more importantly, in the inside, they're simply non-functional. And this is why my windlass is currently not working. So it's important to know what parts to carry around. And windlass parts are extra super important because, you know, if you can't deal with your anchor, you can't. My anchor with the chain is very heavy. It's more than I want to handle. So we're going to replace these in Temptress now, but I'm going to do it on this paper so we can all see the circuit. Let's start at the other end of the equation. This is the battery. Obviously, you're not going to use a battery like this. You're going to need more battery. Now, there's two ways you can go with the whole battery deal on a windlass. Remember, the windlass is up in the bow of the boat, and usually the bulk of your electrical system is kind of in the middle of the boat, which makes sense because it's close to everything. Also, most boats are designed to run lead batteries, and lead is very heavy. You don't want that in the ends of the boat. You want that in the middle. On Temptress, I did something that is atypical. It works great. I've been doing it for over 30 years, so I'd highly recommend it. But like a lot of things on Temptress, I've taken some risks and I've tried some things and kept the ones that work. What I have for the battery that controls the windlass is actually a pretty small battery. It's made by a company called Optima, and it kind of looks like a six-pack of beer because it's coiled cells. And it's a AGM battery that is really good at putting out lots of cold cranking amps. It's a starter battery. And I have that up in the bow, very close to the windlass, with some great big wire running from it up to the windlass to provide power to the windlass itself. Then I run from that back to, well, to a switch so I can control it, but to the house battery so it can get a charge. Some relatively small wire. In the case of Temptress, I believe it's on the order of, I would say 8 gauge, somewhere in there. And that's not enough to run the windlass, but it's enough to charge that battery forward. And then that battery will run the windlass. Of course, the voltage will slump a bit while the windlass is doing its thing. So it gets some power through the small wire, but for the most part, it's on its own. Even when I'm anchored in deep water, I can do a couple failed anchorage. You know, I can drop the anchor and it drags. I can bring it up and I reposition the boat and try again. I probably get, well, I get a minimum of 3, and I usually get the anchor set by 3 times anyway, or I'd be very frustrated. So it hasn't been a burden to have that relatively small battery forward handling this system. Over the years, I would say that was a good thing. So anyway, we're going to start with that. Now, you're going to need a switch to turn off the anchor windlass. The anchor windlass usually has switches on deck, and it's a very powerful device. And if someone got wrapped up in it and like just stepped on one of the switches, because I use the kind of switches you push down with your foot, it could hurt somebody really badly. Also, it could hurt the anchor, it could hurt the windlass, it could hurt itself. So you want to be able to turn it off for sure. And I use this kind of switch. I use this switch simply because when I bought the boat 30 some years ago, it had a switch very much like this, and it fits in the hole. And it's a very heavy duty switch. I have had one of these fail, and you just turn it on and turn it off like that. So the switch would be the next thing in the line. Let's wire that up. So we have from the negative of the battery, well, let's go from the negative of the battery right to where it really goes. It goes right around to the windlass. From the positive side, we're going to go to this switch. And from this switch, we're going to go to a circuit breaker. Circuit breakers or fuses are important on boats because they protect the wires if you have a big surge of power. And if the wires were to be asked to carry too much current, they can get hot. You could have a fire. This is bad. That's completely up to you where you put circuit breakers and where you put fuses. But let me tell you, on a windlass, you want a circuit breaker. You don't want a fuse, because this beast will pop circuit breakers. If you're catching the anchor on something and you're getting a little zealous, now you always should use the yacht's mast to break the anchor free, and that's a different video about how to use a windlass. But occasionally you will overload that, and when you do, you really want the circuit breaker popping. You don't want it to be fused, because now you're in the middle of, oh my God, the boat isn't even being held safely. I got the anchor half up, half down, and I've got to go find a fuse and change it. No, no. So you want a circuit breaker. Not necessarily this circuit breaker, it's just what I had for a model. I personally am currently using an auto reset circuit breaker. So what happens is the circuit breaker mechanism gets hot because too much current's going through it, and it turns itself off, but then it starts cooling. And once it's cooled down a bit, it'll actually just reset itself, usually within about 30 seconds in my case. So if I were to pop the circuit breaker, I just cool my jets for a while. Maybe go back, use the transmission to keep the boat where it needs to be if it's really, really windy. And then I go back and just retry, and I get another shot at that, you know? So everything, the circuit breaker cooled down, but of course that means the wires cool down. Use a circuit breaker. Appropriate to the windlass. The windlass will probably come with a circuit breaker, but they will certainly spec what size that they suggest you use. Now from the circuit breaker, we're gonna, well, let's add one more thing. I like to have a light up here, and it doesn't matter what side of the circuit breaker, because the light's a little bitty thing. But you take the circuit breaker, make a little light bulb, could be an LED, and then you go to the ground. I guess that one should be black. And that means when you turn on the switch, you get to see the light. I make it a nice bright light, and the reason I like a light there is I want to remember that I've forgotten to turn off the circuit breaker. Off topic, this same circuit on Temptress, this same switch also powers the washdown pump, which is anchor related. So the idea being when you turn one on, you want both, but I'm not going to go into that in this video. Here's the meat of the video. These are the solenoids, and I'm going to hook these up and talk about how they work. Now, your solenoids may look different. They may be like a square box, but they have the same terminals. Your solenoids might be made and labeled with indications that they're for use with your windlass. That's not important. All that really means is they're going to be a whole lot more expensive. These are available. I'll try to find them on Amazon, you know, wherever parts are found. The magic word you're looking for, in my case, 12 volt, because I have a 12 volt system, continuous duty solenoid. If you have a windlass that only powers up, you need one solenoid, and if you have one that powers up and down, you'll need two. These solenoids are pretty simple things. They're a relay for all purposes, except a relay that can handle some real power. You should also, by the way, make sure that the ones you purchase are rated for kind of what your windlass can consume. They have two small terminals and two large terminals. The large terminals are actually the big power switch that gets switched. This will turn the windlass on and off. And the little ones are simply the coil, the magnetic coil that pulls the switch together. And it doesn't usually matter which side you use, just that these are for the big wires that control the windlass, and these are for the little wires that come from the switch. One side of the big is going to be going to the battery, and since both of these switches need battery power, I've got this copper bus that I made up years ago. I used it on those. I took it off, cleaned it up a little bit, and we're going to put it on here and bring these together. Ah! So back to our drawing. that power that's coming through the switch, through the circuit breaker, is going to connect right to the battery side of the solenoid. So now the solenoids have positive battery voltage and lots of it available to them. Now, one of these is going to be up and one is going to be down. I tend to mount them vertically on the wall so it's easy to remember. The one that's on the top is for up and the bottom one is for down. So you'll run a big wire from the up to the up terminal, and you'll run another big wire from the down to the down terminal. Should have drawn that better. And that's it for the big wires. That does the thing. But now we've got to make the solenoid actually work. Now, I use these switches, these very switches and temptress. The ones in the boat are fine, so I won't be replacing these today. I'll show you inside footage, but they're actually those stomp switches. Inside the step-down switch is this exact thing. So I can take that switch apart. I can just replace the switch part of it. And in short, when I step on this switch, I make contact across these two poles. And when I release, it goes off. And there's two of them up there, of course. So I have my down switch and my up switch. Never step on both switches at once. It will close both solenoids and will tell the motor to go in both directions. Because you have a circuit breaker, it'll just pop the circuit breaker, but don't do that. It's not a good idea. These are going to go up on deck, but they'll come through the deck and the bottoms of them will be right in the same cabin, right in the same anchor locker as this. So we need to have a source of positive coming to them. I will take that right off the big solenoid side. So there's a wire that goes to one terminal and then jumps around to the same terminal of the other switch. And then from the other terminal of the up switch, we run a wire to one of these terminals of the up solenoid. And similarly, with the down, we run a wire to the positive terminal of the down solenoid. Now the solenoids to activate will need positive and negative, so we grab our convenient negative wire. It can be a smaller wire, of course, and that's going to go to here and to here. Both of these join together. So we've got a situation where the coils have negative coming from the battery directly, and they have positive coming to them through switches that activate them. So recap, I push this button. This one makes a big hearty click. It closes a circuit, the power coming from the battery through the switch, through the circuit breaker, comes through the solenoid, follows the big wire to the up terminal, and spin, spin, spin. The anchor is pulled up. Similarly, if I let go of that and I step on the other one, it activates the other solenoid. Same thing happens. That's it. They're pretty simple. You can add this if you like. Now I have added this to Temptress. I started sailing alone and it was just too much hassle running almost 50 feet forward. So I've added this switch. Now this switch is mounted in the cockpit right by the steering situation, so I can be in charge of the engine and the steering and the windlass all at once. The switch is a 3-position switch, off in the center, on and on. When you do that, that makes a contact between here and here and here and here. It's a momentary switch. That's important. You don't want the switch to lock into the on position. It should pop back to neutral when you're done, because you don't want this windlass to ever be able to just run and run and run. Also, once you've added a remote switch, it's extra important that you have a big shutoff switch for the whole system, because someone in the cockpit might inadvertently bump this switch and while someone's up in the bow. And, you know, like I said, this is very powerful equipment. How to wire this? Really simple. You take a positive wire and run it to the center of this. By rights, that should be a wire that's coming off this switch up here, but honestly, I don't. It's just inconvenient to run a wire all the way back from that circuit. So I just tap into the house positive because they're all connected. And then these two wires run all the way to the bow, and they run right to where these two run. They're the same thing. And it boils down to, if I step on this switch or I push this in the up position, the up solenoid will work. And if I step on this switch or I push this down, the down solenoid will function. That's it. This is not a hard thing to do. The hardest thing about this whole rewiring of the windlass is having these spare parts on your boat. If you're going to go cruising, let me tell you, these are number 1 to fail. These are number 2 to fail. I had this fail once in 30 years, but it was a 50-year-old switch, so this held up pretty good, though I can't speak for modern switches. Circuit breakers are actually pretty good if you buy good quality ones, but it's nice to have spares for things like that. I guess in a pinch, you can always bypass the circuit breaker and just be really, really careful. The windlass itself has failure modes, but they're more mechanical, and honestly, they're, in my experience, pretty tough piece of gear. I use something called an ideal windlass. They're not very popular, but they're still made, I believe, up in New England. They are built incredibly well. And the company, I used to watch Practical Sailor, read the magazine, and that little shout out section when someone would write something about some vendor that did something really nice for them. It seemed like once a year someone was saying nice about Ideal, and it was like I brought in this part and they just put it in their machine shop and fixed it for me because they're just nice guys. I'm really happy with my Ideal windlass. I have had it fail. It's been abused. It was, when I bought the boat, it was all locked up and corroded. I've taken this thing apart, put it on a lathe. I've straightened this shaft. I've recut threads. I have put it back together. Its bones are so tough. It's well worth all the work I've done. I know a lot of the newer windlasses have a lot of aluminum parts. They tend to corrode. Things break. I can't say enough about that Ideal windlass. So you're not going to find it at West Marine. You're going to have to actually look for it. But, how hard is a web search nowadays? I haven't actually checked. It's possible they're out of business, but I hope they're not, because that is a good piece of kit. I hope this helps you. Well, I hope this doesn't help you because you never have a problem with your windlass, but that's going to happen if you go out in harm's way and do stuff. I hope this helps you sometime, at least in understanding how this little circuit is put together. Every circuit you understand is a little more about how you understand electricity. Just going through this video might help you with, I don't know, a bilge pump, because you get to see it happen. I'm going to now put these solenoids up in the bow. I'm going to get this thing all working again, I hope. And then I'm going to do a video on kind of the how to anchor. I'm going to talk about swivels and snubbers and the things that honestly don't seem that popular. There's where do you put your anchor and how much scope you put out, but there's a lot to setting up the anchor gear so that if a storm were to come, the energies are absorbed where they need to be absorbed and things do what they need to do to be reliable. Anchors are a vital device, of course, and they take a tremendous load, especially when things go bad. Especially when all of a sudden the wind direction shifted and it's blowing 40 through your anchorage and you're in 6-8 foot waves right in your anchorage and you're beating around. I've had it happen. It doesn't happen often, but when it happens, you're really glad you did it all correctly. So we're going to go into that in the next video. Thanks for watching my video, and bye from Clark on Temptress.